Hello, everyone. Welcome to MCR for day 2. So today we're going to talk about order of operations, solving linear equations, and then moving those into percent word problems. So welcome. Hope you're having a wonderful day. Again, MCR for day 2 in unit 1. So to start with, when we're going to solve equations and whatnot, we need to have our order of operations down. And I always remembered it as please excuse my dear Aunt Sally, but I have an Aunt Sally. So for the order of operations, you always do parentheses first. And then I'm going to add to this, if you have multiple parentheses, you work from the inside out. So if you have work inside of one set of parentheses, that's the inner, you do those first. Then you would add on the next set of parentheses. And then if there was, say, a multiplication here, you would then do that. So you work from the inside out. We have notation of parentheses, brackets, and braces, but you may also just see them as sets of parentheses, in which case look for the inside and then work your way out. So those always go inside out. And then you do exponents next. So this 4 to the 5th means 4 times 4 times 4 5 times. That goes next. Then you complete from left to right, like when you're reading, multiplication and division, and then left to right, addition and subtraction. So going through an equation, you work order of operations, parentheses, exponents, multiplication, division, addition, subtraction. Or please excuse my dear Aunt Sally. So when I'm looking through practice problem 1, I've got plus, divided, minus. So I'm going to do the division part first, because that falls on this line. So 30 divided by 6 is 5. Then I'm going to write the rest of the equation back in. Now, addition and subtraction just move left to right. So you would do left 20 minus 12 and get 8 for your answer. For question 2, I'm going to go to my innermost parentheses first. So my innermost are this 9 minus 5. And then I'll work inside the brackets and then do the 2 at the very end. So this becomes 4. So I've got 2 times 4 plus 7 times 3 divided by. So each time I'm making sure to write out what I have. So I'm going to put that over here just to give me a little more room. Okay, so now you do multiplication and division left to right. So that's going to give me left to right inside the parentheses. This 14 divided by 7 is going to be next. So I've got 2, 10 plus 2 times 3 plus 2 times 4. And the dot is also multiplication. So then left to right, I'm now going to grab this multiplication. And I can do this one too, because they're separated by a plus, but you can also do them separately. So I've got 2, 10 plus 6 plus 8. Now I can do this bracket, left to right, 16 plus 8 is 24, times 2 gives me 48 for my answer. It's a lot of 2s. All right, pause and try 3 and 4 next. I'm going to go over to question 4. When you see a division bar, it's assumed that there's now parentheses around the top and parentheses around the bottom that you're going to do separately before you divide. So you would do the 3385 minus 3250, 2018 minus 2000. And then when you divide it, it says give the answer as a decimal. So I get my 7.5. And then for this one, my inside parentheses are right here. So I'm going to do that piece first. 6 divided by 3 gives me 2. And then I'm going to write everything else back out here. And even though this was an exponent, I start with the innermost parentheses, which you could also do that one as well. So you could make that a 9 minus 4 times 4 minus 1. So again, I'm going through here. That was my 4. So this is 18 because I'm doing multiplication minus 16 minus 1. That gives me 2, 1. So I end up with 3 as my answer. So then next we're going to take this principle and apply it to solving linear equations. So when you solve linear equations, the idea is that as long as I am doing the same thing to both sides, I can multiply or divide by whatever I want. So 3 is 3. 1 times 3 is 3 times 1. I can multiply them by 2. As long as I do the same to each side, I get a true statement. Same with division. If I have 3 equals 3 and I divide by 3, 1 equals 1 is still true. 3 equals 3 was still true. So I can multiply or divide as long as I do it on both sides, assuming you don't divide by 0. So with that in mind, if I want to solve a linear equation, I want to get the variable on one side all by itself. So I want something like x equals n equals. And how you do that is with inverse operations, moving reverse order of operations. So what that means is if it's 3 plus 2, you want to minus the 2, as long as you do it to both sides. If it's 3 times 2, you want to divide by the 2, as long as you do it to both sides. So multiplication and division undo each other, addition and subtraction undo each other. And if you have parentheses, you now go out to n. So very simply, if we just do division and multiplication, if you have 3x equals 21, you can divide by 3 because that'll cancel out the 3, but you have to do it to both sides. So we end up with x is 7. And if I plug that back in, 3 times 7 is 21. If I come over here, this is 0.5 times n equals 20. It's okay that it's a decimal. I still divide by 0.5. And I get n is 40. And then over here, this is x divided by 2 equals 5. So I undo it with multiplication. And I get x equals 10. All of these, I can go back and check my work. 0.5 times 40 is 20. 10 divided by 2 is 5. So multiplication undoes division and vice versa. And addition undoes subtraction and vice versa. Okay, so for this next one, when we're solving different equations and whatnot, we might have to combine like terms. So if there's an x and an x, you would combine them. So to be a like term, you have to have the same exponent and the same power. Otherwise, you're not a like term. So 3x can combine with the negative 20x because it's kind of like 3 apples, you take away 20 apples. And when you do that, you add or subtract the exponents and leave the variable alone. You can add a y and a 2y. You put a 1 in front, and that would give you 3y. You could add the 5x squared and the 8x squared. You need 5 square feet of carpet, 8 square feet of carpet. You need to buy 13 square feet of carpet. But you can't combine an x and a y, and you can't combine an x and an x squared. So they have to have the same exponent and the same variable. So then down here, you can combine any that have the same variable. So this is 10 and 5. So you would get 15 of these x's. If there's not anything in front, it's not a 0, it's a 1. This is still an apple. So this would be 1.54x. Add the 1 and the 0.54. This is 0.21y plus 1y. So 1.21y. Now here I can add together the 7 and the 3, but the 16 doesn't match because it doesn't have a y. So you leave it. And then for this last one, I like to color code my x's. Put those together, color code my y's. And then put my regular number together. So those are all going to get combined. So it's the x's first, 2.85x. Then I'll do the y's, 8.65y. And then the numbers, 9.34 for my answer. So hopefully that went well for you. So then what we can do is add in. Now we have 4x plus 5x is 9x. And now we also need to go one step further and solve. So I'm going to divide by 9 and get x equals 4. And I can check my work here. 4x, 4 times 4 is 16. 4 times 5 is 20. 20 plus 16 is indeed 36. So I can always check my work on these. So pause the video, try a couple of these, see if you can solve them, and then always remember to check your answers. So going in order for 14, I have a 1 here. So this is 1.75x equals 8.75. Then divide by the 1.75 on both sides. And you would get x is 5. Moving down here, you have a 1. So it's 1x minus 0.20x equals 60. So that's 1.0 minus the 0.2, x equals 60. So I wrote that like that just to show that this piece would become the 0.8x, and then you would divide. And when you do that, x is 75. And again, always plug it back in. You can plug it back in and get 75 minus 20% of 75, which is 15, is indeed 60. And you can use a calculator at any point as well. Okay, this one becomes 1 minus 0.6y equals 2.52. So that's 0.84y equals 2.52. So on that one, I get y is 3. Again, check your work, pause at any time if you want to do the next one. And then this one becomes 1.10 because there's a 1 here. Y equals 185.5. Divide by the 1.10. And I get y equals 165 there. Okay, so hopefully that went well for you. Then we're going to move on and add these in to basic percent problems. So if we recall the steps for problem solving from day 1, we understand the problem and we figure out what we're looking for. Are we looking for a percentage? Are we looking for just an unknown variable? Like number of apples, what are we looking for? Then this step 2 is translate that English into math. And per percent problems, there's some common words that we see that really translate well. Then step 3 was solve. And step 4 is always check your work. And I'm going to add in, make sure your answer makes sense. Am I looking for a smaller number, a bigger number? What am I looking for? So for percent problems, When you see the word of, that means you're going to multiply. When you see the word what, that's your unknown you're looking for. Is your equal. And percent means that you're going to divide it by 100 when you start. So over here, I've got the what is 25% of 56. So I'm going to color code it. And we're going to figure out how to do this. So as I'm thinking about this though, 25% of 56 should be a number smaller than 56 because we're just taking a piece of it. So that's what we mean by, does your answer actually make sense? Common sense wise. So if I accidentally multiply something wrong, I know I'm looking for a number smaller than 56. So the what becomes my X. The what, the is my equal sign. The 25 in green becomes 0.25 because I'm going to divide it by 100 before I put it in. Of 56. And then you multiply them together. So I end up with X equals 14, which is a much smaller number than 56. And I was looking for a smaller number. Next, I'm saying what percent of 32 is 8? Okay, so this time, the what percent is actually going to be my green, the percentage. And I'm going to note that I'm going to change this to a percent later. So I'm going to call this P just to remind me that later I need to convert it into a percentage. So what percent of 32 is 8? What percent of 32 is 8? And then I'm going to divide it. That's going to give me 0.25, but I have this P here. I need the percentage. So I'm going to multiply it by 100% and get 25% as my answer. And then, does it make sense? Yes. 8 is a smaller number than 32, so it should be a smaller percentage. So it works. Okay. And then another one on this page. Again, I'm thinking 7 is 25% of what number? So I want a number larger than 7 because 7 is the piece. So here's my percent. Here's my is. And my of. So 7 is 25%. So I'm going to already reduce it to a decimal of what number is X? Just an unknown. And then I'm going to divide it. So 7 divided by 0.25 is 28, which is a number larger than 7. So that works with what we were thinking. All right, now putting it into more of the homework problems that you'll see in your 154, solving these percent problems. So a good way to start would be to pause the video and just tackle these, see how you do. And then I'm going to go through them all. So again, pause, see how you do, see if you can tackle them. Okay. So his annual salary was $35,600. He received a 3% raise. What's his new salary? Okay. So your salary plus that raise is your new salary. So this is saying what is 3% of 35,600 because that's his raise. Okay. So we would do his current salary plus his raise, which is the 3% of his current salary. The 3% of is the raise. And then that's going to give you our new salary. So if you plug that right in, 35.6 plus 0.03, 35.6, you'll come up with his new salary of 36,668. So then this one is dress is priced at 80. She gets a discount. What's the price after the discount? So I'm looking for a number less than 80, because that wouldn't make any sense if after the discount we pay more. So it would be $80 minus the discount is what you pay. So this is saying what is 25% of 80 is the discount. So it's 80 minus this 20%, 25% of 80, which is 20. So it's 80 minus 20 gives you $60 for your answer. I always find it helpful to really write it out. And then this last one, you have your bill, you have a tip. What's the final amount? So it's the $42.50 plus the tip equals final amount. Okay, so the tip is 18% of the total. What is 18% of $42.50 is that tip. So $42.50 plus the tip gives me the amount I'm going to pay, which ends up being $50.15 would be that total bill. All right, that is day 2. For MCR 4, do the day 2 assignment and turn it in, and have a great day.